Good afternoon, everybody. It's really great to be here with you. As she mentioned, I've been on this job for just 18 days, and this is my first presentation as a representative of Organic Transit. I couldn't think of a better venue, which is just 3 miles away from where I work, although it's a world apart, as I noticed on my drive into the Duke campus. But also the students, the MEng and NEM program students, the bright young faces that I see in front of me. It's actually interesting that it wasn't that long ago that I was in the audience, just like you, looking at somebody for some advice about their journey through life. And today I'm here giving that advice. So hopefully what I say today will be useful to you. That really is the goal of my being here. You might have noticed that the title of my talk is a little bit different from what was in the announcement that was given out. Because as I was working on the presentation, I realized that my journey is from Dearborn to Durham. It's really a tale of two cities in many ways. Dearborn's story is that of Ford Motor Companies. Ever since 1903, when Ford Motor Company was formed, and the whole of the 20th century and the 21st and ongoing, it's really a Ford Motor Company that drives Dearborn because it's the largest employer there. It owns more property than any other entity. Durham's story has been that of American Tobacco and Duke University for most of the 20th century, and then this century, Duke and the Duke health system. What role organic transit will play in that story remains to be seen, but my team and I would really like organic transit to play as important a role in Durham's story going forward as Ford has played in Dearborn's. So what I thought I would do is start off with a brief background of my education, because my education is the foundation on which my career was built. So it's important for you guys to understand where I'm coming from. Then I'll give you a little bit of highlights from my career at Ford. 15 years is a lot of time. There's a lot to be said, but I picked a few things that I thought would be useful for you as you embark on your careers moving forward. Then I'll talk about my decision to move to organic transit. What was it that led me to come here? Some of the current challenges, although they're 18 days old, I've been working with organic transit for over weekends and into long nights for quite some time now. So I have a fairly good idea of what my challenges are and then what I plan to do about them. And at the end, I would leave you with some final thoughts, the things that I've learned over my 15 years, and things that you might find useful as you start your careers. And I'm hoping that we'll have enough time for Q&A. I will stay back after the announcement, so if you have any burning questions, feel free to ask. And then if we run out of time, I'll leave you my email address so you can correspond with me afterwards. So education. This page is quite full, so you can see that I like to be in school. So starting chronologically from the very beginning, I obtained my bachelor's or undergrad degree in mechanical engineering from the Indian Institute of Technology in Delhi. There I was able to work hard to earn the Director's Medal for highest GPA in my graduating class. And the reason I mention that is because academic excellence has always been important to me from the time I was in grade school. And for those of you who are from India, you know how you're basically competing with hundreds and thousands of other people from the day you were born. And then that kind of gets into your DNA. But actually what I found was I enjoyed learning. I enjoyed getting into depth into things. And I enjoyed being first in class. And that has stayed with me throughout my career and even through grad school and into the MBA program. The question to ask is, does academic excellence or success in a classroom necessarily result in success in the workplace? So there are some lessons from my experience that if you're interested, we could explore in the Q&A session afterwards. So while I was at IIT Delhi, I was quite concerned about the state of air pollution in Delhi. Delhi was already a very polluted city. There were no emission controls. The gasoline was unleaded, and basically by the end of the evening, you would have soot all over your face if you were walking anywhere. So I decided to study combustion. I thought that was something would be my way of understanding how things burn and how we could make them more less polluting and more efficient. So I applied to several universities in the U.S. and the top of my list was Illinois, which admitted me with a fellowship and a research assistantship. So I joined Illinois in '92, right after graduating, and I worked with an applied mathematician by the name of John Buckmaster. He was in a theoretical and applied mechanics department, and we studied how flames would grow in microgravity while I was there. It was a really interesting, challenging problem. We were looking at mathematical ways of modeling combustion in space, and we had some data from the space shuttle. But during this time, I realized that I really enjoyed more applied work than fundamental work. So I moved for my PhD to work with a professor who did research on internal combustion engines. And just one semester after I started with him, he decided to move to Michigan. So all of us, all his graduate students packed their bags and moved up with him to Michigan, and that's where I finished my PhD. And Michigan had strong ties with Ford's research labs, so I was able to get an interview and impress them suitably that they hired me. And I basically stayed in the research labs for 14, 15 years. And then I changed into another organization. And then after 14 years, I realized that I needed to speak the language of business. Not just understand it, but speak it fluently. And that's why I decided to go back to graduate school and earn an MBA from the Ross School of Business, which makes it easier because they're very close to where Ford is. So that's my educational background. And at Ford, basically, as I said, I've worked in two big organizations. One, excuse me, I have a sore throat, it's kind of catches up a little bit. One was the Research and Advanced Engineering from '98 to 2013, and then the Electrified Powertrain Engineering Organization, which actually designs and builds all of Ford's full hybrids, plug-in hybrids, and battery electric vehicles. And I left Ford a few weeks ago to join Organic Transit, which all you know is based right in your city. So in terms of highlights of my career, I've picked 6 different areas that I think would be useful to you to know of. One is Six Sigma. It's a methodology. Systems engineering, which again is an approach or a methodology. Something that I developed at Ford called the Global Technology Development System. I worked on many different advanced powertrain projects. My background was combustion and engines, but I'll highlight one of them just to show you how interesting some of these things can be. And then I moved more into the business side of things after I finished my MBA. One was multi-attribute optimization. In any complex system, you have multiple attributes that you're trying to optimize at the same time. The question is, how do you figure out where you need to be in the overall multi-dimensional space that defines those attributes? So I'll show you one example. And then the last year I was at Ford, I worked on electrified vehicle product strategy, figuring out how Ford should, or what Ford should design in its hybrids, plug-in hybrids and battery electric vehicles to capture market share. So Six Sigma, how many of you have heard of Six Sigma? Very good, great. So I don't have to go into too much detail. That's nice. I hadn't heard of it when I was in grad school. So Six Sigma is a structured, data-driven methodology to reduce variability in a manufacturing process. And the Six Sigma performance goal basically means that you have less than 3.4 defects in a million opportunities. And so you're essentially fitting 12 standard deviations between the upper and the lower spec limits. It's an extremely stringent target to meet, and very few companies are able to achieve that. There's 2 flavors of Six Sigma. The more conventional one that most people know of is called the DMAIC methodology, which actually is an acronym based on the 5 different steps in the process. And this is used in manufacturing, where you have tons and tons of parts or products being built, and you're trying to assess or reduce the variability in those parts. So the first step is the define, and which actually is the most important one, where you're defining what problem it is that you're solving, and why is it a problem for you to solve. Then you go into the measure phase, which is, before you take any data, you have to have confidence in your measurement system. So here we call it measurement system analysis, or gauge R&R. So if you give me a data point, if I have no idea what the variability in your measurement system is, there's no confidence in where the data point actually lies on your two-dimensional, three-dimensional space. So reproducibility and repeatability are really important steps in the measure phase. So once you've figured that out, then you go and analyze the data to characterize the problem and see where you stand. Once you analyze it, you know what the problem is, then you go into the improve phase where you look at design of experiments and other techniques which allow you to move from where you are today to where you need to be. And then the last step is control, which basically means that once you've made a change, you have to ensure that that change will stay in place after you have left. So there are techniques like control charting, etc., that are used to ensure that this happens. So that's the more traditional DMAIC process. What's more interesting for people who are developing new technologies or working on new things is a design for Six Sigma process, which basically, instead of being reactive in a way which they make is, it's more proactive because it designs out defects from the very beginning. So you design a product in a way that it does not have defects in it. So it's also called failure mode avoidance. So it prevents defects to meet or exceed expectations of future projects. And it also starts with define. And that's something I would like you guys to think of very carefully. Because define is the most projects fail because they're not defined well. People don't know what it is exactly that they're trying to solve. They don't understand the scope, what is within the scope and what is outside the scope. So in DFSS, once you've defined, this is what I'm trying to do, then you characterize it. You figure out the relationships between the outputs and the inputs. Once those are known, then you optimize it using responsive surface methods or design of experiments, techniques like that. Then you verify by building a test rig or building some kind of a project to make sure that what you set out to attain has actually been attained. So that's Six Sigma. Very similar to Six Sigma is systems engineering, which I personally believe is one of the most important approaches or techniques that every engineer should know. Because we have moved out of doing component design, we're designing very complex systems these days. And to be able to do them well, it's really critical to understand the entire system. The system, the subsystems, the components, and how they interact with each other. At Ford, the way they look at systems engineering is a V-shaped process, where you start from the top of the V on the left, you move down, and then you start climbing up the right side of the V. At the top of the V on the left is our vehicle level or system level requirements, and they come from customers, they come from company objectives, they come from regulatory requirements, or anywhere else where requirements would come from. And the main idea is that you know that whatever you're going to do at the end of the day is going to meet some customers' expectations or requirements. And once you know the big system level requirements and you cascade them down to system level architecture and system level requirements, then you go into hardware and software design. And this is a very iterative process as shown by this double-headed arrow. And there's a lot of time that needs to be spent on this side of the V because you're trying to relate requirements to specifications and design. At the end, at the bottom of the V, you've done your hardware and software implementation. Then you start basically building your hardware to validate the design. This is the verify phase in design for Six Sigma. And then you're constantly comparing these two at this level. So at the end of the day, when you've done your attribute testing, it should meet the expectations of the customers that you started with. So out of this grew the Global Technology Development System, which a very small team at Ford put this on as a challenge. And I was basically the leader of the team which we operationalized the Global Technology Development System. And the idea is if time is on the x-axis, what happens typically, and failure modes found are on the y-axis, what typically happens is as you go further and further in time, you find more and more failure modes. Because if you haven't done your engineering right, if you haven't followed the systems engineering process, as you start building the system, you'll start finding more and more problems. The issue with this approach is that the countermeasures for these problems become very difficult, disruptive, and costly because you've built the hardware by that time. the ideal approach would be to flip this process where you find more and more failure modes early. So instead of sending an army to launch, which is what most automobile companies do, you should send an army to the research and advanced engineering organization where you're actually doing the design upfront. And if you do it right the first time, then you will basically have almost nothing to do when the project goes to launch. And that's a very critical element of the thought process which requires a cultural change in mindset. And while we were working on this, we found these two quotes that I really like. One is from Richard Feynman, says, for a successful technology, reality must take precedence over public relations, for nature cannot be fooled. And this is the last sentence in the Challenger disaster report that he wrote after Challenger blew up in 1986. And the other quote that I also like very much, I found it in a book on railroads in the 19th century from Ralph Waldo Emerson that says, every excess causes a defect and every defect an excess. And that's very true too. You have to find the right balance in coming up with countermeasures. The other learning point here was, as engineers, we are very focused on the technical side of things. And technical failure modes are failure modes of not understanding customer requirements, not doing the right amount of work that is required, failure modes that are undiscovered, and or inadequate or poorly verified countermeasures. What we don't focus on are the business-related failure modes, which are lack of understanding of the value proposition. It's fine if, as an engineer, I come up with a great solution, but what if nobody cares? What if nobody wants to pay anything to buy it? I know that's really important to understand too, before you even start working on your solution. So that's one of the drivers, and actually we did a study at Ford of projects that had failed, and we found that more than 80% had failed because of business reasons, not because of technical reasons. Engineers are smart; they can figure out things. It's not the engineering or the technical part that's the issue. The issue mostly becomes about the value proposition and not understanding it and not being able to communicate it to people. Let's say, for example, at Ford in a big company, if you are in one small part of it, how do you communicate it to people who have the purse strings to give you the funds that you need to continue forward? And the third thing also that's important is project management. A lot of times, especially scientists and engineers, they don't like to make plans. It's very constraining to make plans. So, but again, if you're working in a complex system where you have huge teams and you're relying on resources from many different parts, you have to have a plan. You have to know what your resources are and things like that. So all three are really important to keep in mind. This is just one project that I did, which is quite interesting. So the rest was mostly process. This was actually a project. It was an engine that we built that runs on two fuels. It has gasoline in the main tank, which is injected through a port fuel injection system, just like old cars. And then there is E85 in a smaller tank that's injected directly into the combustion chamber. And by doing so, you can make a gasoline engine more efficient, almost as or more efficient as a diesel engine. And you can get tremendous amount of power and torque out of it. And the reason for that is the gasoline has very high energy density, but it is very susceptible to knock. And E85 or ethanol has 30% lower energy density, but it is a great fuel because it has high heat of vaporization and a very high inherent octane rating. It's a great fuel for engines that knock. So if you design a system in a way that it mainly ingests gasoline, but when it starts knocking, you inject only the amount of E85 required to avoid knock, and you can get the engine to work perfectly. So this was just an example, and the idea of having two fuel systems basically forces us to learn a lot about what it is to control engines with two different systems, to stretch the boundaries. We were generating 600 horsepower from a 5-liter engine, 900 plus foot-pounds from a 5-liter engine. So those kind of things, and you learn about how do you stretch the material, about heat transfer, about fatigue, and about lots of very, very interesting things when you're stretching the boundaries. So by this time I'd done my MBA, and I decided I wanted to look more into the business side of things. So, well, like I said before, a lot of times we need to know when we are in a complex environment, we have multiple different attributes that we are trying to optimize how to do it. So this is just an example of a platform of vehicle concept selection where the requirements are coming from many different sources. So they are regulatory, they are customer wants, technical, and then you have different options. You could design a vehicle, you could choose the material, you could make the vehicle plastic or aluminum or steel, you could, excuse me, pick the powertrain, you could make it a gasoline engine, a diesel engine, a hybrid engine, an electric vehicle, plug-in electric, hybrid, something else, maybe an L, the different types of fuels, etc. And then you have business requirements, profitability. I mean, one thing to keep in mind always is for you to be or your company to be successful, it has to make money. And to make money, you have to figure out how judiciously you use the resources that are at your disposal to get the best value out of it. So we created this tool that allowed us to compare the different options in these kind of Pareto charts. So you take any functional attribute on the x-axis, could be, let's say, fuel economy or carbon dioxide produced. So if it's fuel economy, you're trying to maximize it. If it's CO2, you're trying to minimize it. And then you could have some sort of a business metric on the y-axis. Could be operating margin or return on sales or net present value, anything like that. And then you compare the different solutions and then you walk along the Pareto lines. And this allows you to know, so if you have thousands of solutions for a given function attribute, you really want to be at the top of this surface. And that's for the Pareto frontier. So this is one way of knowing how to optimize a system. And this is my last slide on my Ford experience. So during the last year, I worked on a project strategy for a hybrid, and Ford currently has 6 different electrified vehicles on the market. The top 3 are the hybrids, full hybrids, C-Max, Fusion, Mondeo is in Europe, and KZ. And then we have the 2 plug-in hybrids, and then the battery electric vehicle. One thing interesting about Ford's approach, which is very distinct from Toyota, which made the Prius, or GM, which made the Volt, or Tesla, or Nissan that made the Leaf, is those are all dedicated vehicles. These are vehicles that were built for just that particular application. Whereas here, these are normal cars. These are Fusions and Focuses, which you can buy with a conventional engine any day. So there's nothing distinctive about these vehicles, and that's on purpose, because the idea is the power of choice. The customer should decide what variant of that vehicle they want, rather than being forced to pick something that's bigger or smaller based on what the manufacturer thinks it should be. Of course, you will see the charge port here on a plug-in, and then here on a plug-in, and that's the fuel port. So you can tell from the external appearance, but in general, they are not very different. And so there's challenges with that approach, because you're now constrained. You cannot optimize the vehicle. The vehicle determines where you put the battery, and that becomes really important when you have a battery electric or a plug-in where the battery is really huge. And so there's very, very interesting challenges with that. So we worked on that. And then, so I'd been with Ford then for 15 years, and I decided I needed I needed a bigger challenge. And I was feeling a little bit underutilized, let's use that word. And I wanted increased responsibility. And one thing that had been on the top of my mind for several years was this whole challenge of mobility in the 21st century. And I wanted to address it in a direct way. So the 20th century was really defined by Henry Ford's invention of the moving assembly line, which made personal mobility very affordable. And I really like this ad which Henry Ford took out in 1925, when Ford Motor Company was at the peak of its power. It owned 60% market share globally. And in that ad, he expressed his vision for mobility, which was opening the highways for all mankind. And they showed this young couple on the top of a hill playing with their kids, and there's highways teeming with cars, and then factories, representing growth and opportunity, showing progress. It's interesting that if you look at the same ad from 21st century eyes, you see clogged highways and you see pollution. And that really is the challenge for mobility in the 21st century. Yes, we can move, Yes, it's affordable, although it's not as affordable as it should be because there are 7 billion people on this planet and only 800 million cars. So the rest 6.2 million people are basically walking or cycling. And that's not fair. So the question is, for the 21st century, is sustainability in all its different facets. And that is a great challenge for mobility now. And there were actually 7 grand challenges that were identified by the World Business Council for Sustainable Development, which is actually formed by several car companies and oil companies. And they said these 7 problems are conventional emissions of what we call tailpipe emissions that come out if you have a conventional vehicle. The stuff that comes out of the tailpipe that is not so good for the environment, for the air that you breathe. So carbon monoxide, hydrocarbons, nitric oxides, particulate matter, and lead. And then there's the greenhouse gases, the CO2 that comes out. Most people are aware that CO2 leads to warming. So that's not such a good thing. And then there's traffic-related fatalities, traffic-related noise, traffic cause congestion. And these problems are getting more and more amplified now that the rest of the world has caught on to the automobile. In China, there was a traffic jam that lasted for 14 days. And although in the US, deaths have gone down, very, very significant improvements in reducing fatalities on the roads. They're skyrocketing in different parts of the world. And the other 2 are social issues, which are also very important. The mobility divide between the haves and the have-nots. And this is not just rich and poor countries, it's people within a country. If I look at Durham, for example, there is the rich part and there is the not-so-rich part. There are rural areas that don't have access to mobility as much as people in suburban areas. The urban areas don't have access to mobility. And then mobility opportunities that are available to the general population. A lot of people don't have access to cars. There's only 800 million of them and 7 billion of us. So these are all problems or challenges that we have to solve together to make mobility sustainable in the 21st century. So while I was thinking what I should do, I met this cute little vehicle called the Elf, and life just changed overnight. I met the CEO of Organic Transit, that's a company that makes the Elf. On one Saturday morning, I went to see him. I had just written to him, hey, I'm interested. I have this background. He said, come over. We met at 9 o'clock. We didn't even sit down for the next 2 hours. And it was 6 hours later that I was sure that I wanted to work for Organic Transit because we saw so much in common with how we feel mobility problems should be addressed. And the ELF is a great solution. There's no perfect solution. There's always trade-offs you have to make. It's a hybrid between a bicycle and a car. Cars have great use, and that's why they've been around for 100 years. Bicycles have their own advantages, but the idea is to take the best of both worlds and try to combine them in a package that is fun, it's light, and it's electric. So just some specs on the ELF. It's the world's first sun and pedal-powered trike. So it runs on 3 wheels. It runs on solar power and on your power, your human pedal power. So theoretically, you don't need to burn any CO2 to run the ELF because you can use the solar panel to charge the battery, and you can use your own power to move it. Rough calculations we have done show it's about 1,800 miles per gallon gasoline equivalent. It weighs 150 pounds. It has 350 pound towing capacity. There's a lady that goes to the Durham farmers market who uses every ounce of that 350 pounds available. She carries 264 pounds of stuff every Saturday to the Durham farmers market. It has a 600-watt electric motor. It can go maximum speed 30 miles per hour, about 15 or to 20 on electric. But then if you are a good bicyclist with strong legs, you can go further to about 30. 15 plus miles electric range, but it can be increased if you buy a bigger battery. The battery charges in less than 1.5 hours. And then if you just use the solar panels, you can charge it in 7 hours. And the whole point is healthy people, healthy planet. In a way, it keeps you healthy, and it keeps the planet healthy. So what are my challenges at Organic Transit? My role is of the general manager, so I'm responsible for all operations of the company, marketing and sales, engineering, manufacturing, finance, and working really very closely with the CEO to move the company forward. So Organic Transit is at that stage where we have sold 300 elves over the last year, but we want to sell 1,200 this year and then 5,000 to 10,000 next year. And that scaling up is really the challenge that we are now confronted with, and we have to solve. In many ways, actually, you might ask this question, how is it different working for Organic Transit than Ford? And actually, interestingly, it's not that different. In my day-to-day work, I'm confronted with three challenges: project, process, and people. Project is, if something breaks on the elf, it's all about engineering, understanding if there's a failure on an antler, it's a fatigue problem, or is it something else? On a car, it's the same. Ultimately, it's about the engineering of that product. People are the same everywhere. Yes, they may be from different backgrounds or the different education levels, but the way to motivate them, I find, is very similar. And process is interesting. At Ford, over 100 years, we have developed lots of processes that work. At Organic Transit, we are actually writing the book as we are reading it because of just lack of resources and the small time that the company has been around. The big difference I see is that the resources are limited. We have few people, we have tons of things to do. And so we need to be very clever in what opportunities we decide to pursue. Every day we get 15 to 20 emails from people from all over the world wanting to be dealers, distributors, partners. How do you figure out which ones are legitimate, which ones are not? So that's really a big challenge right now. For me personally, getting the team organized, building the team and seeking the right partners are the key near-term priorities. And ultimately, we want to build a company that will attract really bright people who want to make a positive difference and provide them with an exciting and productive career. And you guys are especially welcome. We have some Duke interns working with us this summer, so that's a really good thing. We would welcome you guys to spend some time with us if you have time over the summer. We can't pay much right now, but we can give you an experience that you will never forget. So come see us. We are just 3 miles away. I saw an elf parked outside as I was turning into Science Drive. So I know there's several faculty and students at Duke who ride elves. But we'll give you test rides if you just come. Let us know ahead of time, and we'll schedule test drives for you. And I'm really looking forward to an exhilarating career with Organic Transit. Before I end, just one last slide, some final thoughts. These are just based on my experience so far. I would encourage you to be passionate about at least one thing. There's 7 billion of us on this planet, and there are probably more than 7 billion problems that need to be addressed. We don't have to solve each of them, but if each one of us can solve one problem, take responsibility for one, this planet will be a much, much better place than it is today. For me, that passion is helping underprivileged children. For the last 10 years, I've been volunteering for a children's organization that tries to bring sustainable change in the lives of underprivileged children in India and in the US. It's called CRY, Child Rights in Youth. And I've also volunteered in the Big Brothers Big Sisters programs. I mentored a boy. He was 13 years old from a disadvantaged part of Detroit. And we've become good friends over time. He's now 22 years old. But I was like an older brother to him. And that experience taught me a lot. And I think it's something that I will keep for the rest of my life. So these things will enrich you. These things will make you a better person. And definitely something that you will feel proud about doing. The second thing I would say is follow your heart. It seems like a cliche. As engineers, we are taught to respect data, and I strongly recommend that you do. Data is really important, especially when you do your measurement system analysis and you can believe that data that you're seeing. And even as business people, and I was actually so surprised when I went through the MBA program that there was so much emphasis on data, even in marketing, which I used to think was just fluffy stuff. But there's a lot of market research that's done, and data does set you free in many ways because it takes out ambiguity in your decisions. However, it's not every time that you know you have the right data, especially when you're looking ahead. And you know, one thing you know is what you have is probably not correct when you're trying to forecast things in the future. So I would say, especially in terms of career choices, follow your heart because that's when you will do the best that you can. If you go into something just for money or just because somebody says you can become the CEO, if you follow this path through the organization or that path, it's not going to work out if that's not what you really want to do. If you are finding yourself dragging yourself out of bed to get to work, that's not the right place for you. The third thing is learn from patterns in your life. A lot of times when I look back, certain things happened when I was young, certain things happened that at that time felt like anomalies. Maybe it just happened because it happened this way. But when I look back, they consistently happened in a very similar way. So that's something you should, maybe something is telling you that this is the way things happen for you. It could be circumstances outside your control, but a lot of times these are from within you. So, for example, if you really like to do well in school, and school is limited to 3-month or 4-month classes, so you put in a lot of intensity in really doing well in that class, and then when the class gets over, you jump onto something else. So you see this pattern, and if you see the same pattern at work, where you are working really, really hard for 3 to 4 months, and then you're moving on to something else, even though the project still stays and you become a little bit bored or not as productive, that's telling you something. So listen to these things, keep an eye on these things, and ask yourself, oh, the same thing happened again. Is this telling me something? The last thing is don't forget to have fun. Sometimes we take ourselves very seriously, more seriously than we should. Most of us will live a long life. Life expectancy is 79, 78 for men, 81 or something for women. And as as the new generations come, people will be living more than 100 years. That will be pretty normal. So you have a long life ahead of you. So don't stress out too much about time and then I have to do this within the next 2 weeks, and enjoy the people you are with because they will change as you will change, and these times will never come back again. So just have fun, have some plan for yourself, be passionate about something, and then try to make the world a better place.